Okay, so welcome to your FRQ help video for the week of 9:30 through 10:06, 10:07 I should say. So in this first one, we have the integral of a second derivative function, and it's got a 2x in there. And it's a definite integral, so we must plug things in. The clue here is u substitution. So I mean, suppose I had this for a second. I'm just going to make up another example. All right. Well, what we're going to do is we're going to say that u is equal to 8x, which means that du over dx is equal to 8, which means that du over 8 equals dx, right? And so we're going to go back and we're going to redefine this. We're going to say g double prime of u, and that's going to be du over 8. And I'll take that 8 out, put it in the front. We also need to find our new upper limits, and you get that by plugging in your numbers here. So let's see, u is equal to 8x. So if I were to plug that in here, I would get 72. And if I were to plug in 6, I would get 48. Okay, so there's that. So after you do your u substitution, you go ahead and do your integration. Now the integral of a second derivative would be like taking one of the derivatives off, right? So it ends up being a first derivative now. And then from there, you're going to go ahead and plug in your stuff. So we would have g prime of 72 minus g prime of 48. So your two big ahas here is the fact that you need to do your u substitution, and that's your u. Don't forget to change your limits. The other big aha is that the integral of a double prime is a single prime. Okay? So that's your helpful hint for the first FRQ that's been assigned to you guys. Let's go ahead and jump down to the next one. All right. So on this one, they give us a couple of initial conditions. If f of 0 equals 2, f prime of 0 equals -4, and the second derivative also. F double prime of 0 is 3. So the first problem is saying that this is the function g. A is just a number, so it would play the role of just like a 2 or a 3, for instance. And our goal here is we want to find both g prime of 0 and g double prime of 0. Okay, so I'll go ahead and walk you guys through that. First of all, so we have g of x is equal to e to the ax plus f of x. Let me double check to make sure I've got that written correctly. Yes, okay. So if I wanted to find the derivative, well, g prime would be, when you take the derivative of e, it's just the same thing, but you also need to multiply it by the derivative of the exponent itself, which would put an a there. Remember, that a is like a constant. So if this was like e to the 2x, for instance, the derivative of that would be 2e to the 2x. Well, since a is a constant, we just don't know what it is. It's going to do the same thing as this constant does, right? That number just comes to the front. The a stays where it is. Then we have f prime of x, right? So you take the derivative of each piece. You're going to repeat that process to find your second derivative. So once again, if you take the derivative of e, it's going to stay the same. Now we already have an a in the front, but if I take the derivative of this expression again, I get another a in the front, which is going to make it a squared, and then f prime becomes f double prime. So there's your first derivative and second derivative. The next thing we have to do is you get to plug in your zeros. So you guys got to plug in 0 for g prime and 0 for g double prime. And I think from there you guys will get it. So I'm going to go ahead and shut up and let you guys do the rest. But there you go. Let's go ahead and take a look at the next problem. So we have another function here. And it says, once again, k is just a constant. So it's just like the a here. It's written as a letter, but it really just represents a constant, unchanging number that we just don't happen to know the value of. Our goal is to find, first of all, it's asking us to do two things. To find h prime and also to write an equation for the tangent line. Okay, so let's go ahead and step back for a second here. I'm going to do an example that's like it, but I won't do the exact example, okay? I'll do one that's like it. Well, first of all, notice that this is a chain rule, and the whole thing is a product rule. So let's start off with the product rule. If I wanted to find the derivative, it's going to be AB, AB. We'll call that A, we'll call that B. Remember, it's prime and prime. So if I take the derivative of this, the derivative sign would be cosine, right? Don't change the inside, but then we do the derivative of the inside, and that's a constant, right? So just imagine that being like a 2. Well, you just end up with a 2 in the front, right? But since we're dealing with k, we're going to put a k in the front, and we don't change the b. Over here we have a, and let's leave it as is, and then we have b prime, which would be f prime. So there's that. So there's your, that's how you find the derivative. That's the first question they want you to do, is find the derivative. The next thing they want you to do is find the tangent line at x equals 0. Well, how do you find a tangent line? Well, you need an x value, which they gave you at 0. Then you need a y value, and then you need your slope, right? Well, to get your y value, you plug the x value, which is that thing, plug x into the original equation. That would be this thing. So plug in 0 up there, and you'll have your answer. To find your slope, you plug 0 in to the derivative. So you're going to plug in 0 to this equation here for x. Once you have your x, your y, and your slope, you go ahead and just do this thing. So this is old news. We've done this 100 times, so I hope after that little refresher there, you guys are well on your way to solving that one. Let's go ahead and take a look at the last example, or the last problem. There's not really much to discuss here for number 6a. I feel like, first of all, if you guys are watching this video a little bit early, this can't be completed until after we've done lesson 2.14. So if you haven't done that lesson yet, just kind of chill back and wait a little bit. We're going to do that this Friday. But if you have done lesson 2.14, part A is pretty simple. I'm going to let you guys go ahead and do that. There's not much to discuss there. I think that part B is a little confusing. Basically it's saying, suppose that we have the slope everywhere in this plane. How would you describe all the points where the slopes are positive? Well, this is the slope, right? dy dx. And dy dx is equal to x squared times x minus 1. Now this piece here, that's always positive, right? And we're multiplying that by something, y minus 1, and we want to know how will it be positive. Well, that's the question. Since this piece is always positive, the question here is what values of y will make it so that this is positive, so that when you multiply these, you end up with a positive. So I'll start the sentence for you. The slopes are positive where y is blank. You fill in the blanks. The slopes will be positive anywhere where y is equal to what? I'll let you guys see if you can figure it out. That's my hint to you. Let's go ahead and take a look at the last one for a helpful hint. Find the particular solution to the differential equation with the initial condition. This one's pretty basic, pretty straightforward once again, I think. So I think what I'll do is I'll go ahead and, even though letter C is pretty much kind of like what we'll be doing in class, there's kind of some interesting little details along the way, and I think it's kind of worth me just doing it with you guys. So let me go ahead and switch slides here. We'll need a little bit of space. Here we go. So right now what we have is we have dy over dx is equal to x squared times y minus 1. Okay, the first thing we're going to do is we're going to separate our variables, right? So I'm going to divide both sides by y minus 1, and I'm going to multiply both sides by dx. if I do that, I have the following. And then we integrate both sides, right? Okay. Now, for the side on the left, that's pretty simple. Just the old power rule there. For the side over here on the left, if we say that u is equal to y minus 1, the derivative of u with respect to y is going to be 1, and therefore du is equal to dy. And so we are going to integrate this as u instead of y minus 1 du. Oh, oops, I made a boo-boo. This was supposed to be 1 over y minus 1 if we divided it. So now this is 1 over u. Sorry about that. In the beginning, I was supposed to divide the y minus 1. If I did that, it would be 1 over y minus 1. But we're still going to do that u substitution thingy. Okay, so now we have this, which means now we've got ln of the absolute value of u is equal to x cubed over 3 plus c. And once again, we're going to go ahead and put back our u value. And this is where things get a little bit interesting. So now what we're going to do is we're going to exponentiate both sides. We talked about that in class. So we're going to make both sides the power of e. And these cancel each other out. And what you're left with is the absolute value of y minus 1 is equal to e to the x cubed over 3 plus c. Okay. All right. Now something else that we talked about was how we wanted to separate these, right? And e to the c is really just another c, and so we're just going to put a c in the front. Oops. Okay, so there's that. Now the absolute value bars create an interesting situation. Notice that if I pick, what values of y would I have to pick to make sure that this is positive? Well, not that. Let me back up. What values of y would I have to pick to make sure that this is positive? The answer is anything greater than 1, which, by the way, is your answer to part B. So for anything where y is greater than 1, this piece inside will already be positive, right? Which means in that case, y minus 1 will just be the positive version of our expression that we have here. But for anything where y is less than 1, the absolute value will change its sign, right? And in that case, that means that y minus 1 would be equal to the opposite sign of what we have over here. Okay? Now, in our particular, this is the part I'm concerned about. So understand, you basically take this expression y minus 1, set it equal to, or not equal to, but greater than 0, solve for y, and this is the part that will, this is the part that will tell you where it's positive, and the opposite will be where it's negative. Okay? So that's the big part. Now the second big part is deciding which equation we're going to use, and it all has to do with this initial condition over here. It says f of 0 equals 3. Well, in this expression here, which of these numbers is the y value? It's that one, right? Now let me ask you, is that greater than 1 or is that less than 1? The answer is it's greater than 1, right? So that means we will not be using this piece, we'll be using this piece. And from here on out, we're going to go ahead and use this equation to solve our problem. So that's kind of a tricky one. Those absolute values kind of make you have to evaluate two different possibilities, and you have to determine which one actually is the one we want. Now I'm going to move the 1 over here, so it's plus 1. And to find my c, I'm going to plug in my initial condition. So if I plug in 0 here, this whole exponent becomes 0, which means that's just 1, and 1 times c is just c. So now I've got 3 equals c plus 1, which means that c equals 2. And I have my final answer now. Y is equal to 2e x cubed over 3 and plus 1. There it is.